let's talk more about some of the specific elements. So for example, say we're looking at the periodic table and we're looking at one specific element, boron, which has the symbol B, and it has an atomic mass of 10.81 and an atomic number of 5. So knowing what we know about atomic mass and an atomic number, we can say that the number of protons is 5. Remember, that corresponds to the atomic number. That means that the number of electrons is also 5 because the atom is neutral. And we know that the number of neutrons is the atomic mass, so let's round that to 11 minus the atomic number, which is 5, to get 6 neutrons. The neutrons and protons are located in the nucleus of an atom. So 4, 5, 6, 7, 8, 9, 10, 11. So we have protons plus neutrons in the nucleus. If we were to develop a model of that, say that that is the nucleus. Then we have this cloud of electrons around the nucleus. And those electrons are in what are considered energy levels. So the first level can only hold 2 electrons. The first level closest to the nucleus. There are a couple different ways to delineate these energy levels, but for right now in this class we're going to use the KLMNOP method. So this first level is the K level, and now we've filled up that level now that it has 2. The next level is the L level, and the L level has the capacity to hold 8. So K has the capacity to hold 2, L has the capacity to hold 8 electrons. If this is the case, we can fit more electrons in this L level. We have 5 total that we need for this atom of boron. So we've already used 2, and we can fit 1, 2, 3 more. So now we have a total of 1, 2, 3, 4, 5, and we've checked off all of our electrons for the element boron. So this model here, you can either draw it without the nucleus or with it, is considered a Bohr model. And the Bohr model is useful to understand how the element kind of looks. Knowing that it has 1 full energy level for the electrons in the K level, and that the L level is not full. It only has 3 of its possible 8 electrons, so it might want to pair up with another element out there and combine. And the reason it wants to do this is because elements want full energy levels. So an easier way to even see about how reactive an element is going to be is to actually draw a Lewis structure. So if we were to keep the same element, boron, remember it has 5 protons and therefore 5 electrons and 6 neutrons, we can just say that the element boron, we know that its first energy level is full because we're going to take 5 minus 2 and we're going to have 3 left. So all we're going to do is draw those outer electrons. Any full inner energy levels we are not going to include in this Lewis structure. So again, the Lewis structure is really useful in determining what's considered the reactivity of boron. We know that it only has 3 in its outer level, and it wants to have a full level, so it either wants to get rid of those 3 electrons or take on 5 more so that it has a total of 8, and that second energy level L will then be full. So in the Lewis structure, we only draw the very outermost electrons. So we would not include that inner K energy level because it's full. We're just including the L outer energy level. And this is a typical way to draw it, where you draw the element symbol here, so the B. So if we were using chlorine, we would do Cl. If we were using carbon, we would have a C, and then we would draw the outer electrons around those. And those are the basics for Bohr models and Lewis structures. If you need to, rewind this video and make sure that you really understand how to draw each structure.